And welcome to the EPA's Computational Toxicology Community in Practice. I am Sammy Hant. I'm a student services contractor here at NCCT. Today we'll be hearing from Dr. Richard Judson about ToxValDB. Before we get started, I would just like to everyone to just be reminded to please mute their line. If you have any issues with the sound, please let me know in the chat, and I will try to solve it from there. And without further ado, give it over to Dr. Judson.
Great. Good morning. Thanks, everybody, for calling in.
Thank you.
I'm going to give a
quickly mute those lines. I'm sorry, everybody.
Yeah, we're getting some feedback from some of you folks. Okay. All right. So I'm going to tell you a little bit about a new database we've been building over the last couple of years called ToxValDB, where what we're doing is trying to pull together lots of publicly available in vivo toxicity data, at least to index it so that you know what data is out there. And this is any of you who use our computational chemicals dashboard. This is the data, the in vivo data that goes in there. So I'll get through this, talk about the database, show a little bit of application, and then we can have some time for discussion. Okay, so and again, there's still some people who are not muted. It'd be great if you could mute, please. So the drivers for this, there are several things we're doing here. One is the Rapid Tox project, which some of you may have heard about, where we have thousands of chemicals that need some kind of risk assessment done on, and you can't do 3 to 5 year IRIS assessments on all of them. And so the goal was to have a tool with some data behind it that we could do some rapid risk assessments in hours to days. And to do that, you have to have data. And then there are a number of prioritization applications. Right now, many of us are deep in the TSCA, helping the TSCA people and OPPT do prioritization. And so ToxVal is a big source of data for that. And then finally, there is modeling applications where we'll never be able to go into animals and measure the effects of tens of thousands of chemicals. So if you can take data for chemicals where you have it and build QSAR models, then you can make initial predictions anyway. And I'm going to, at the end of the talk, I'm going to talk a little bit about a couple of QSAR applications that are being built off of the ToxVal database. Okay, so ToxVal is aiming to meet these needs, and what we're trying to do is bring in as many in vivo studies as possible. All this data is public, so we're not pulling data that you couldn't find some other way, but just a lot of data is hard to surface, and it's hundreds of different places. And so what we're going to do is at least make it easy to find the initial data. And we're going to focus initially on quantitative values. These are the toxicity values. So NOEL, low-L, a reference dose, so on. And we won't have the full study details. Quite often that information simply doesn't exist in the public domain, but we can often capture these NOELs and low-Ls. But the key parameters we're going to capture are things like study type. Is it an acute or a chronic or a reproductive study? Is it an oral and inhalation? Is it a 90-day, a 2-year, what species, and so on? Where possible, we want to capture critical effects. And again, where possible, we're going to have links to the original study document. Some cases that exists, some cases that doesn't. And we're going to make it all accessible online. One thing we're not doing here, and I may come back to this a little bit later, is doing thorough literature searches to find what is not already captured in one of these online sources. That's certainly on our radar to do that, but we haven't done that so far. Okay, these are the key data sources, and I'm not going to go through all of these other than to say we have multiple databases, data sets from the US EPA, from ECHA, so the REACH data, we have at least an index into most of the REACH data. EFSA, the European Food Safety Agency, has recently put out a database of, looks like ToxVal of their chemicals. DOE, DOD, ATSDR have databases of these values. Cosmos is a big database put together by the FDA and the European Cosmetics manufacturers on in vivo data for cosmetics and food ingredients. And you can see we have some other smaller data sets. One point to make about this is if there are data sets you know of out there that we haven't captured, please let me know. I suspect there isn't very much of these large public data sets that we haven't looked at. I got an email earlier today about why is not NTP here. We actually capture NTP largely through the EPA ToxRef database. We've pulled in most of the repeat dose studies there. So some of these databases are databases of databases. Okay, so what is a toxicity value? It's one of these quantitative values that you get out of an in vivo study. So it's a low L or a no L, maybe an LD50 from an acute study, maybe a benchmark dose. You can then, add safety factors to those and get reference doses and reference concentrations. And then there are other kinds of reference values that various agencies, so ATSDR or the military or Cal EPA put together these EAGLES or MRLs or RELs or MEG, military exposure guidelines. Then there are the equivalent ones from cancer, so the slope factor and the unit risk values. And a lot of U.S. federal state agencies put together these screening levels. So what's an acceptable daily intake for food, or what is an acceptable concentration for the chemical in surface water or drinking water? So we have all of those sorts of things. Okay, why is this hard? In principle, it shouldn't be too hard. But the problem is every one of these 20 or 30 major data sources and all the minor ones, everyone structures their data in a different way. They use different terminology. They use different units. So mg per kg per day, there's 47 different ways people can spell mg per kg per day. So to build the database, we have pulled in, we pull in files, or we have web scrapers that scrape data and into, lots and lots of individual files. Sometimes we have Access databases or MySQL databases or Oracle databases. We then pull all of that into, we pull vocabulary we need and develop these vocabulary fields. People have, you name a chemical 17 different ways. So we have to have a common way to name chemicals. We use the DSS Tox system to do there. We finally want to have something called the study type. This is just an example of one of the controlled vocabulary fields. So because different databases have a field called study type, we left that as the individual databases used it, and we have this field called risk assessment class, which is acute, chronic, and so on. Then we have the value type, the ToxVal type, which is the low L, no L, et cetera. We convert all of the values, the units, into standard ones. How we spell mg per kg per day. There's 17 different ways to spell rat, if you believe that. So we have to map all the species, strain, rat, and et cetera. You can see all the rest of this. And where possible, we capture the study information, the journal, the year. Nancy Baker in our group is helping me extract. A lot of times we just have a title going to PubMed IDs. And so then that's all done, and we do a lot of automated curation. We have lots of scripts we built that try to clean all this up. Over the next year, we're building a manual curation tool which will let you look at the record in the database and look at the source file to the extent we can get that, and somebody will manually say, did these match up, and try to clean all that up. So the problem is that even if we just look at the points of departure, low L's, no L's for human and ecotoxicology, there are about 700,000 records. So we're certainly not going to get through that many. Okay, just a little bit about the database structure. Let me build myself a pointer. Okay, so we have a table which is chemical, which has in the chemical, the chemical structure information. Most of the data then goes into this single table called ToxVal, which has many, many fields in it. We know the relationship between different records, so you know this is a low L and it's matching reference dose. We have that. The study details, which again has the title, the PubMed ID, and so on, goes into a different table. And then we have these vocabulary tables, and these are just some examples. So species is a controlled vocabulary, and how we describe ToxVal, and we have some dictionaries that end up showing up, fields end up showing up on the dashboard. We have nice, hopefully clear definitions. Then we're starting to pull in genotoxicity information, cancer data, and skin and eye irritation data, and it's structured a little differently, so we have our separate tables for that. And then finally, we have this whole cloud of other mini databases, which often have more detailed data from a different source. So, for instance, IRIS, maybe we have more detail than fit into the main ToxVal database. So there's somebody on the phone who is shuffling papers or eating their lunch, and everybody can hear that. So stop it, please. Okay, so a little bit about the cleaning process with more detail. So again, we have all of these different sources come in. They go into the ToxVal source databases. That gets put into the ToxVal database. We add all of the references, data quality, and information. We clean up terminology, and these are I think these are all of the individual terminology areas. Then we say, okay, we want to know, is this relevant to human or ecological species? What's the risk assessment class? We transform units. And actually, let me just say one thing about this. So we would like, or some of our customers would like, to be able to, for instance, all studies, whether they're an oral or an inhalation or a dermal study, to be converted to mg per kg per day. And there are various reasons why you'd want to do that. And we have the ability to do that, but we've discovered, any of you who do inhalation studies or dermal studies know that that's not a one-size-fits-all process. So right now we're not doing that. And for instance, for inhalation studies, how you do the conversion is different depending on whether the endpoint or the effects are portal of entry or they're systemic effects. And quite often we don't know that, and so we're having to come up with some way to confirm that. Okay, then you do all of this, and then we start flagging records for being funny. So is the exposure route and the units and the study type, do these all match? If you have an oral study with units of mg per meter squared, okay, there's something funny there, and so that says somebody should look at that. And then we finally will do some QC pass or failing, and there is some prioritization filtering, which is application specific. I won't talk more about that. Okay, I mentioned this earlier, that cancer and genotoxicity are being handled separately. Cancer data there are really two kinds of cancer data. There are these definitive sources like IARC that study a chemical. They have a panel that studies a chemical and finally has one of these classifications that says it's a probable, likely, and so on. So it's not a quantitative value, it's a sentence. We can also have data coming from individual studies. So somebody ran a 2-year rat chronic cancer study, and there's a critical effect, which is liver tumors. Okay, so we know that that's a cancer study. We know there's cancer there. And then we also know, studies can come up with a cancer slope factor, a unit risk value. So it's all of that kind of heterogeneous data, which we use to understand whether a chemical has potential carcinogenic effects. And in genotoxicity, we have We have data from these sources.
I think many of the policies in this bill are deeply unwise to allow early release.
Just a quick reminder for everyone to please mute their lines. You can accomplish that by hitting number 6. We're not due to technical, lack of technical.
Okay, and as with all of the other kinds of data, everyone uses different terminology. We call an Ames assay 43 different things, and so we've had to map all of the different assay names to a common set of names, and Grace Petlevich and the group, along with some other folks, did most of that for us. The data there, even though these gene tox assays often will have a quantitative value, so it's a concentration where you saw an effect, most of the data sources don't give us that information. And we've also been told by our gene tox experts that it's really hard to compare a quantitative value from assay 1 to assay 2, and so, for all sorts of technical reasons, we're not capturing that. We're simply capturing the original study type, the standard study type, and was it a positive or negative value. Okay, just some overall statistics, probably not readable, but these are the major data sources, and here we're talking now just about the in vivo studies, not about the cancer and, well, I guess cancer is mentioned, but you can see the major data sources just by chemicals are the Ecotox database from Duluth here at EPA, the iEuclid, and we actually get ECHA through 2 different ways, the ECHA reach data. There is a database we can query directly, but it's not up to date, and we're working with ECHA about that. And then you can go through eChem portal, and you can download data, and even though the eChem portal version is a little bit lower than the iEuclid, turns out it's not a subset. There's some chemicals you get in one and some chemicals you get in the other, and many chemicals you get in both. But the 2 different sources give slightly different pieces of data to use. Then TEST, this is a big database Todd Martin at the EPA developed, and this is all acute data. Then the EFSA, I don't remember what their database name, Food Safe Tox, something like that, is next. Cosmos, EPA, HPVIS, then ToxValDB, which is mostly pesticides, but all the NTP data is here, and so on. So it pretty quickly drops off. We have several databases with 1,000 or more chemicals, and then we have things with just a few tens of chemicals. And if we just look at LEL or NEL, these are, NEL is a NOEL, a NOEC, a AEL, and so on. So we have a few thousand chemicals that have at least one study with a no effect level, a few thousand with at least one study with a lowest effect level. A handful, maybe a couple hundred with benchmark doses. It's 10 to 15,000 chemicals with LD50s, with acute studies, and so on. So it's, most of the data we see is coming from this top half. It's a handful of big databases, which are mostly low-ELs and no-ELs and LD50s. Okay, so that's really the basic database, and now I want to just walk through just a few applications that we're using this for now. One issue that we're very interested here is the uncertainty and variability in vivo data. So if you run a study, a new study on a chemical, and you get a low-EL of 1 mg per day, what is the likely range if you were to run that study 4 or 5 times? And we can start to answer that because we have enough studies in the database that have multiple, we have enough chemicals where we have multiple studies of the same study type. We're looking at that. And we've actually published 1 or 2 papers. We have some more coming out on this, but we're looking at these issues. What is the experimental variability and how is it driven by species, strain, dose range, and so on? What kinds of experimental issues might be there? How do statistical power issues drive these errors? we see reporting bias. Some databases will, if you don't look for something, they won't tell you they didn't look for it. Some databases will say they looked for it and it was negative. And so there's always this reporting bias we have to deal with. If we dig into some of the detailed study report, then we can actually start to see there's report bias. So we'll have the full study report and we'll have a summary, and the summarizer said there was no effect. And if you go, another person goes in and looks at the full study report, says, yes, there was an effect. And a big issue is this diagnostic terminology drift. So over the years, what you call a phenotype, something you see in a study, has changed, can change over the years. And of course, there's all of this data assimilation that quite often what we may see in a database may be the third iteration. There was the original publication, it got pulled into one database, that got pulled into a second, and so on. And so there's typos and transcription errors. Okay, just a snapshot of the kind of information we can see for uncertainty. So I've got two examples here. These are subchronic mouse, AEL levels. And here we're just plotting where we have, again, two studies that are both subchronic mouse studies, two different labs. And this is the NOEL from lab 1 and this is the NOEL for lab 2. And they're more or less on the diagonal. But the spread here is, and this is a histogram of the spread, you can see a number of studies where we have more than an order of magnitude. So this is 1 order of magnitude, 2 orders of magnitude. And the average or the median difference is about half an order of magnitude. So, if you say that my NOEL is 1, okay, it's really 1 plus or minus an order of magnitude. If we look at subchronic rat NOELs, we have a lot more of those. The median deviation is about the same. So that's kind of comforting that there's not a, and we see this across other study types, so reproductive studies. So the average, once you control for the endpoint type and the species, it's about a half order of magnitude. Okay, so now I want to switch to talking about QSAR models. And the first one is built by a postdoc in the group, Prachi Pradeep. She's out just having had a baby, so I've let her do this, but she's still out on maternity leave. And the goal here is, again, for mammalian studies, we have lots of chemicals that never...
Can I just ask one more time, hopefully, that everyone please use their lines, and once again,
Okay, so the goal is to be able to have a first order estimate of the point of departure, a low L or a no L, for a mammalian study, and again, building it based on this pretty big data set we have. So it's pretty standard QSAR modeling work that Prachi has been doing. And so, she starts, again, with the data set I just talked about. We have these different kinds of effect levels, and so she's going to look at low L's and no L's in benchmark doses and other kinds of points of departure. Quite a lot of studies. It's many more rat than mouse, a few rabbit, and she's building models specific for rat, specific for mouse, specific for rabbit, and then building models where it's all together, and then building separate chronic, subchronic, reproductive, developmental, subacute models, and then finally models where you just throw everything together and have the species and the study type as covariates. So, there are all sorts of games one can play. They're looking for clear, and the reason for doing this, I'll just say for people who are not expert here, if you wanted to build mouse chronic or rabbit chronic studies, you only have 342 values, and so it's hard to build a good model. Models, the more data you have, the better the models are, but the more heterogeneous the data is, the worse the models can be. And so what she's looking at is kind of a trade-off between how specific the model is, which has this data power issue, and how broadly applicable the model is, where you throw everything together and at least try to control for some of these covariates. Another issue that she's bringing into these models, which is kind of novel, is the standard QSAR model gives you finally at the end, you put a new chemical in and it gives you a value. But since we know that the underlying data is uncertain, she's building models that actually will give you a value with some kind of a uncertainty value around it. And so it's really mapping this experimental variability that is the input to the model to the model uncertainty, which is the output of the model. And just some, preliminary results. So this is the observed, this is the predicted, this is the training data. And so we have an R squared of 0.42, and RMSE, root mean square error, of about 0.76. This is 0.76 log units. So remember the in vivo data, you do 2 studies, and on average you're off by about 0.4, 0.5 log units. And so the model is somewhat higher, obviously, than the data, but it's less than twice as, the uncertainty in the data output is less than twice what the model uncertainty is. And so this, again, this is the training set, this is the external validation set. And another reason why this is a little difficult, if we look at this distribution over here and just look at the red, this is the distribution of points of departure. These are low L's, no L's, benchmark doses across all of these chemicals. It doesn't span a very large range. Most chemicals, the low L is somewhere between 1 mg per kg per day and 100. There are a few chemicals below 1 mg per kg per day and a few above 100, but actually a pretty good estimate. If you don't know anything about a chemical, would say, okay, my point of departure is going to be above 1. And this is really the basis of the TTC. TTC is actually looking at the lower 95%, which is down here into the 10 to the minus 2 or so. And another application I won't mention other than to mention it is there's some folks here in the group taking all of this data and looking at, can we do an update to TTC? There are other people who are doing that for certain chemical classes, but we can in principle do a better job just because we have a bigger data set. And then finally, this is the final slide on Prachi's in vivo point of departure, the mammalian point of departure model, where she actually takes into account both the input and the output uncertainty. And again, it doesn't make a lot of difference. You're still, the root mean square error is about 0.7. And here's just a plot showing, the input, the observed uncertainty bounds, and the output uncertainty bounds, and they're about the same order of magnitude. Sometimes the observed uncertainty is a little bigger than the model, and sometimes vice versa. Okay, so that is working its way through. I think we have to do one more run with the latest data and then get the paper reviewed and submit it. So hopefully by summer, this paper will be out in the literature. Okay, and then the second model I want to talk about is really the same thing, only for fish, so aquatic toxicity, and this is being developed by Thomas Sheffield, another postdoc here in the group, and more or less the same approach. And so we're going to look for points of departure in fish and use the ToxVal database, which is 80 to 90% ecotox, again, the Duluth database, but we also have fish data from some from ECA, some from EFSA, some from other databases, and using a variety of covariates as features. The ecotox, the fish studies are not as rich in study type land as mammalian, So what Thomas has done is simply built an acute, an LC50 model, and then a repeat dose chronic study looking at NOx, LOX, and other kinds of endpoints people report. And then the endpoints are typically just growth, mortality, and reproduction. And that all goes in what he's calling the NOAC model. Okay, so again, it was about 90% ecotox, 10% ECA, with a little smattering from other places. There's a lot of data, which is really great. So there's, for the LC50 model, there's 35,000 experiments, 2,600 chemicals, but there's 360 species. And so all that species diversity makes the database very heterogeneous, and that's a potential issue that again, Thomas has looked at. NOAC is 15,000 experiments, 22,000 chemicals, and 221 species. The model is built on PhysChem properties from OPERA, PADEL, it's a standard feature descriptor set, and then experimental covariates, which are these, exposure route, but then this taxonomy group. And so what Thomas did was to take all of the, starting up here at a name I can't pronounce, which has many, many species in it, and say, okay, there are certain species subcategories as we go down the phylogenetic tree that have enough data that it's, we can build specific models or use specific covariates for this model. So we might be able to build a generic fish model, which is everything, or a model which is specific for Anguilla rostrata, and so on. And this chart goes down many, many levels. And so all of these relatively well populated species groups are covariates in the model, can be used as covariates in the model. One thing, again, we need to understand is uncertainty in the database, and these are just the 10 or 15 most studied chemicals, and this is the acute data. And all we're showing here is the LC50s, the log 10 LC50s across all of the studies. So if we look at dieldrin, we have studies, LD50s, that go 10 to the minus 4 mg per liter up to 10 to the 6 mg per liter. But then, there's a big group down here. And some of this variability comes from experimental covariates we don't know about. Some of it comes from species and so on. Or, and John Arnott just said, and some of that is well above water solubility, right? So people actually don't filter for water solubility. Thank you, John. Anyway, so you see this variability, and if we look at the inner two quartiles, that's about 1 order of magnitude or so. So the variability here is sort of the same size as we saw with the mammalian data. So again, if somebody says my LC50 is 1.357, no, it's 1.357 plus or minus half order of magnitude or so. And one hypothesis that nobody, as far as I know, had looked at, but we just looked at is that you would expect an acute study, the longer you run the study, the lower the dose where you see the effect. And so let's just look at atrazine over on the left. And so this is the range of the acute studies, the subchronic, and I don't remember how Thomas divided subchronic for chronic, and then the chronic, and you see sort of a nice trend. So as you go to longer times, the dose where you see an effect goes down, and these are statistically significant changes. There are other chemicals like ethinyl estradiol, where the dose is about the same no matter what time. So the effect shows up at a very early time in the study. So you don't have sort of an accumulation of effect. And so just an interesting fact. Okay, so the a little more on the data variability. And so here, for the LC50, the median, these are standard deviations. So it's a half a log unit or 0.8 log units, depending on whether you have the LC50 or the NOAC. And again, these are the chemicals where we have enough replicate studies to do statistics on. And then if we see, these were chemicals with 10 or more entries, and these were experiment groups, so species, so it's a little more more defined. And as you make the study groups, you're looking at more homogeneous, you actually see the uncertainty drop down. So again, this says, as the models are being built, if you are too generic of what you call a fish or a study, you have a lot of input model uncertainty. So it's really important to add these covariates in as the models are being built. So it's just some generic findings from the acute, the LC50 model. The root mean square error is about 0.8 log units, but 81% of the chemicals, their predicted values with 1 order of magnitude of the experimental value, the nominal experimental value. And if we go back to the previous slide, even when you take into account covariates, the uncertainty in the experimental value is about 0.4, 0.5 log units. So, you know, the model uncertainty is larger, but not drastically larger. For the NOAC, the repeat dose, the results are about the same. So the RMSE is greater. So for the LD50, it was 0.8, and here it's 1 for the RMSE. And before it was 81% were within an order of magnitude, and here it's 76%. For the sake of time, I didn't put the comparison, but there are 2 standard models that EPA uses currently in regulatory work where we don't have experimental eco data. There's the TEST model and the EcoSAR model, and Thomas did a comparison with both of those. And this model outperforms both of those, both in terms of RMSE and the number of chemicals within this order of magnitude. And principally, it's because we have a much bigger data set. You know, it's a newer, bigger data set. And if the other models went back and retrained with the bigger data set, they would probably improve. And we've talked to Todd Martin, who's the developer of TEST, and he has our data. And if he has time, he's planning on reparameterizing TEST with the newest data. Okay, so just going back to ToxVal in general, some ongoing work. We're continuing to do automated data cleaning, and we're developing this manual QC process. We want to bring in new data sources. We're working with the folks at ECA, which is a very, very rich data set, to get all of the data they have, and it's a combination of technical problems on their end. It's just a complicated system, as well as some policy issues. Both, you know, all of you who deal with regulatory offices know about policy issues with releasing data, and so we're fighting some of that. The Comptox Chemicals dashboard, where you can actually see the ToxVal data, and I don't remember whether I want to talk about, I'll go ahead and mention it here, and I'll skip when I get to it later. ToxVal is in there. So if you go to the Comptox Chemicals dashboard and you look at toxicity data, you see this. What's in the dashboard is somewhat out of date. It's probably 6 to 9 months out of date. And we're very grateful for people who find mistakes in the data there and send us messages, which we then go and fix things. We're hoping certainly by SOT, to have reworked things so what's on the dashboard will reflect the latest, cleanest data in the database. then accessing literature data, and this is something that Nancy Baker in the group is helping me with. We would like to be able to say, okay, here's a chemical. We actually, not only have a reference that might have a no L or a low L in it, but we've guaranteed it actually does. And then we could queue that up for manual curation. And exactly how we do that, basically we've recognized this is a big challenge. But it's one that if we don't do, collectively we don't do, then we know there's going to be big data gaps for anybody using this data. And then, as I mentioned at the beginning, there are multiple ongoing applications. The QSAR models, we have 2 that are close to getting ready to submit it, and some others we're talking about prioritization, and then the rapid tox application. Yeah, okay, and I just, one more word about the dashboard. We're not quite up to date, and we are working on redoing the user interface to make it a little more data rich and a little easier for people to use the data and drill down into more details. Okay, if you want to access the data, again, the kind of old data is on the dashboard. There is an FTP site, and I should have just actually put the FTP link here. This is a live link. Are we posting these slides? Okay, so the slides will be posted, and if you click on that link in the slides, it will take you to the FTP site where there is very close to up to date. It's once every few weeks I post the latest data files. It's just a big upload in Excel, and there's one for mammalian data and one for ecotox data. And you're free to download that and to use that. Again, this is all public data. There's no secrets there, and so I feel comfortable letting people get access to that. Yeah, Monica just showed the link there. And since I think my last slide is my acknowledgments, let me do that, and then I'll come back and actually pull up the FTP site. So this is a big effort by lots of people. Duncan McPherson did a lot of work before he left, and he was in charge of ToxVal for a while. I've taken that back over. Katie Paul Friedman works, and Sean Watford are working on the ToxRef, which is a big database. There's a bunch of people here working on the dashboard. Prachi and Thomas, I want to mention, are working on the QSAR model, and cast of thousands. This is an oldish picture of the NCCT. So let me go back here and see if I can. Release my your option. Having done that, had a fancy pointer, I can't get access to that, so.
It's like control, click.
Yeah. All right, sorry. Get out of stuff here and control, click. Okay, so here is the URL. So I'll just leave that up here, and you can see there are these 2 large data files. There's the human health, the eco health. There's a dictionary which defines all of the columns and the types of ToxVal, and then there's a README that tells you a little bit about what the files are. Okay, so that's what I have to say, and I'd be happy to take questions. Thank you.
Yeah, it looks like we have one question that someone asked earlier. So let me see. This is from Annie Jerebeck in ORD, and they want to know, is there any notation when a value represents a peer-reviewed or vetted estimate, or indication that a specific study served as the point of departure for a chemical assessment?
You have to infer that. So, and you can kind of infer it from the source. So if it's an IRIS value or a PPRTV value, then it is peer-reviewed. Whereas if it's an HPVIS study or a REACH study, it is not. That's really the only level. And then if you want to know what the POD is for an assessment, we do in the database had the links between the reference dose and its underlying point of departure.
Okay. It looks like they are typing, so.
Okay.
I,
Yeah.
this has come up in the Rapid Talks meeting. So if people come across articles that they want you to put in ToxVal, is there a queue they can send the manuscript of the article to? And
So the question is, somebody wants a study put in, could they just send it to me? No, we don't have any way to do that right now. Someday we will, but please don't just start sending me studies. It'll go into somewhere in my inbox. Okay, so.
Yeah, so I guess they just wanted to say it might be to explain which values were vetted in response to the earlier question.
Okay, so let me wait for Annie to explain. Okay, yes, so we actually do have a database field which will record that. That's a good point. Yes, in fact, somebody from the Rapid Tox group, which Annie has been part of, asked us for that, and we just don't have that populated right now. And let me go back up to Carol Merchant's question. Do you have plans to update your database when the underlying databases are updated? And this is a really good point. So when ECHA updates their database, how do we make sure that we are in sync with them? And we kind of do that on a manual basis. So I keep track of when databases are updated. We have a couple of people, so Jamie Vale and Doris Smith, who are in charge of some of the databases. They do update, pull data from the source databases, look on a quarterly basis. So we try at least to do a quarterly basis, but it's not automated. We have to do that by hand. Okay, guess number 2. This is a good question. Is ToxVal the same as ToxRef? No, they are two different things. So ToxRef, which is an older database, which Matt Martin started developing and Katie Paul Friedman and Sean Watford manage today, is a much more detailed. There's a lot of detailed data down to the study group level, and it mainly covers pesticide actives, NTP studies, and a few literature studies. So it's maybe 1,000 chemicals, 1,500 chemicals, something like that. ToxRef summarizes ToxVal has summary data from ToxRef in it, but it doesn't have all the details. Again, ToxVal has kind of this summary data, what's the study type, the species, the chemical, the point of departure. And it's the same thing, if you go to reach data through eChem portal, you see a lot more data than you would see with what you see in ToxVal. Okay, so Emily Thunen, why does the database control for laboratory? How does it control? Yes, okay, that's more sensible. Thank you, Emily. We simply report the values, so we don't really control for it. We just let you know, okay, here are 3 studies from 3 different labs for the same chemical, the same study type, and you can see that. Okay, Carol asked another very good question. Is it possible to tell whether entries coming from different databases are derived from the same or different original sources? This is really hard, but really important. So, I'm just going to give a for instance. So we have IRIS. We have data from IRIS. And then there's a paper Jessica Wignall published a number of years ago where she took data from IRIS. And there's a paper by Wei-Shui Chu who took data from IRIS. And we have values from all 3 sources. And there's I'm not going to say whether anybody did it or not. One or the other of those secondary sources might have mistyped something. So we might have 3 different values. And we need to know, okay, what is the original, which is the original one and which is derived. Again, we have the ability in the database to track that, we haven't implemented that. But that's a really key
You'd
thing.
have to go to IRIS and then find out the reference in IRIS where they got that data, right?
Correct, yes,
and
right.
And then go to that.
Right.
So you're not even tertiary, you're like...
Yes, right. So there's a lot of nice things we know we need to do that we just haven't done yet.
Right.
Okay, and again, Carol's, going deeper into Carol's question, it really is important to understand what's the primary study value and what is just a copy of that, and what's a mistaken copy of that, because that really does affect our notion of what variability is. Because if all we're doing is detecting variability in me making mistakes when I copy things, that's not very interesting. We've got another coming from Emily. Okay, well, somebody's typing. Does anybody want to speak up and just say a question? Okay, if not. So Emily's question is how different NOELs from different agencies are treated for the same study. That's complicated. So the places where this might show up is, so for instance, Dow submitted a study to EPA, and then Dow submitted a study to ECHA. And they may have a NOEL, but then those two agencies might have done some assessment. They're experts to come up with the AELs. And sorry, my computer just went to sleep because I was not. And so you might get two NOAELs for the same study, corresponding to the same NOEL. And I'm sure those exist. That would be another case where we would have to go and map all that together to understand how that's done. Does that at least address, whether it answers, at least addresses your question, Emily? Yes, thank you. Okay, guest 2 is typing. Okay, are the values listed in ToxValDB lists? No, there is no, right now there is no ToxVal study quality, but if the original source has a study quality flag, we do capture that. So ToxRef has a study quality flag, ECHA does, Hawk does, most of them don't. But the databases with lots of data, some of those databases do have study quality flags that we then surface. We have maybe another query coming in. Yes, all points of departure are not created equal. That is exactly true. And going back to an earlier comment, John Arnaud threw up there, their studies with chemicals in fish at orders of magnitude above the solubility limit. So clearly those are bad studies that have gotten into the databases and are not flagged in any way. So those studies, I know that we were showing there, passed through some study quality filter to get into that Ecotox database. So, there's a lot of buyer beware here. But I think, maybe this will be my final comment. It's better to have the data available than not, but you have to be careful and do a little bit of curating yourself in any application of using this data. Okay, if there are no other questions on the phone, thank you for all muting yourselves and keeping it muted. And, one more coming through the typing. 2 more. Yeah.
Feel free to ask any questions. This might be your last chance, everybody.
And Merry Christmas, or Happy Holidays.
Yes.
Happy Holidays to everyone. Okay.
Okay.
Okay. Thank you, thank you.
Cool. So yeah, I guess we're going to take that as a wrap up right now. Yes, everyone is just saying thanks. So once again, thanks everyone for coming, and yes, happy holidays.